Hello, my colleagues, and I hope everyone is well. I had a question on homework at Chapter 7, basically the last one, 11 of 11. I guess and that's B7-11. You're considering opening a new plant. The plant will cost $100 million up front and will take 1 year to build. So there's your initial investment right away, right? After that, it is expected to produce profits of $3 million at the end of each year of production. The cash flows are expected to last forever. So as soon as you see the word forever, that should be a tip-off that that's a perpetuity, right? The cash flows are expected to last forever. Calculate the net present value of this investment opportunity. If your cost of capital is 8%, should you make the investment, and then calculate the internal rate of return. All right, so here's your annual profits, right? I'll highlight that, and here's your initial investment. All right, I'll highlight that, and your cost of capital or opportunity cost is 8%, and they want you to get the net present value, and they want you to get the internal rate of return. Okay, the internal rate of return, as a reminder, is the spot where the net present value is equal to 0. And as long as your internal rate of return is greater than your cost of capital, you do the project. That's the rule, okay? You do the project. So let's look at the cash flow for this problem. All right, here's the cash flow, and you can see the word forever, right? So it's a perpetuity. So it's 100 million negative your initial investment, and here are your cash flows. So let's look at the solution, and it's not too bad. Again, here's the timeline. They give it to you again. Now here's the net present value as an equation for a perpetuity, right? Now again, you're not going to have to use this, but I have to show you a little trick to use Microsoft Excel. But they don't really care. All they want to know is the net present value greater than 0? And I'm sorry, yeah, great. So it is. So since the net present value here calculated is greater than 0, you make the investment. All right. So now they also want the internal rate of return, and we could probably use these in Excel. First of all, let me do the net present value in Excel, okay? So I brought up Excel, and I mentioned to you already that Microsoft Excel's net present value is different than the net present value we normally know. So now you got to be careful. This is a perpetuity. So how do I show an infinite number of payments? Well, I can't do that. But what I do is I trick Microsoft Excel for a perpetuity, and I make it look like it's an infinite number of payments. I put like 100 30s. And you could fool around with that, all right? But you can clearly see what I did. At 8%, I went from cell A2 to cell 105. So I got over 100 payments. Now, it comes up with this number, which is pretty close, but again, we have to subtract off the initial investment. So I'm going to say, okay, there it is. But again, now I have to subtract off $100 million, okay? I believe that's what it was, right? $100 million. All right, so where did it go? So you see, in the actual equation for net present value, they subtract off the 100 million, okay, and it comes out to 247.22, okay. But I again had to go in here, and you see this comes out to like a little bit higher because I didn't put enough 30s. But there's your answer, and you have to subtract off 100 million. So that'll give you the net present value. Remember, net present value is a little different in Microsoft Excel, and you got to subtract off the initial investment yourself. But that'll give you that answer, okay? Now you notice they calculate they use this equation and set the net present value equal to 0 to get the internal rate of return. So we don't have to do that. So the internal rate of return comes out to 24.16%. But again, in Excel, I'll just bring up Excel and I'll bring up the internal rate of return function. There it is, right? And basically, let me move this out of the way. And I'll just put the values in here. Here's the 100 and here's all the 30s. Again, I had to simulate a perpetuity. There may be a way of doing it in Excel. I don't know if the function's in there. And if you find it, you can hunt it and find it, and I'll give you extra credit. Right? So okay, so what I did was I brought up the internal rate of return function, and I put a whole bunch of 30s to simulate a perpetuity, as I said, right? And now there was one thing I didn't catch right away. There was one thing I didn't catch right away, and that is the fact that the first year was the first year was 0. If you look at the timeline, all right. Let me go back and look at the timeline again here. Get a lot of stuff open. You notice this is a 0, right? So basically, that's the way that worked here. And all right, so but you can clearly see how it came out to exactly. Let me scroll down for you. 24.16%. Again, for a perpetuity, you got to just fool it a little bit, all right? And that's what the book got, right? 24.16%. Okay, so I hope I was clear about that.